Okay, I think finally we can start. First of all, thanks for your interest. You are a lot of students. I think that you know that we have only 200 seats for this course, for this subject, which ran out of availability after about 1 week. And then I got several emails from students asking for the possibility to subscribe, meaning that there is indeed a very high interest in this topic, climate change. We know that, of course. We know that the interest is indeed very relevant. So you are the lucky ones. Some of you are attending in presence, some of you are attending remotely. The nice thing of this subject is that it's a soft skill course, which means that there are several backgrounds among the students, several different backgrounds. I am used to teach at engineering, and I must say that I'm happy to say that I'm really excited by the opportunity to teach for the second time to an audience that is mixed in terms of background. This is really, I think, important. We all know the value of diversity, but it is difficult to achieve diversity in practice. Instead, I think that diversity is a relevant added value, especially when discussing about relevant and global challenges. It's important to confront different opinions. It's important to listen to different interpretations. And this is why also this subject is not taught only by me. You will see other 3 professors. I will teach for 12 hours, and then the other 12 hours will be delivered by colleagues. Professor Alessandro Gaggini, Professor Antonio Navarra, Professor Veronica Rossi. Because I think it is indeed very interesting that you listen to different interpretations, different scientific interpretations. Now, this course is taught in English with a simultaneous translation in Italian. And both the recordings will be made available to you. So it's not compulsory to attend the lectures, either physically or remotely. You have the opportunity to see back the lectures if you want to review some of the topics, or if you miss some of the lectures. You don't have to be concerned by your physical or remote attendance. It's not a problem. I think that this subject also lends itself to the possibility of attending remotely, and offers the possibility, the opportunity to attend offline. I think it's really not a problem, because my treatment of the subject will not be very technical. Given that you have different backgrounds, my treatments needs to be very descriptive and very conceptual rather than technical. I will focus on the concepts, not on the models. So I think that this is another consideration that gives to you the possibility to attend also offline. Of course, it's better to attend online, because if you have questions, we may have an interaction. But again, it's not a problem at all. On the other hand, I would like that you know that I'm very pleased to have physical interaction with you. Because last year, I taught actually only a couple of lectures like today, and then I had to pass to remote teaching. And remote teaching, actually, I don't like it, for the reasons that you may I think you may get easily. For a teacher, it's very important to have an interaction with the students. And by looking at your eyes, even if you are quite far from me today, I can understand whether my teaching is efficient, is corresponding to what you are expecting. And if I miss this physical interaction, then it's more difficult. And especially for this topic, I think the physical interaction is important. So the moral of the story is, please feel free to attend remotely or to attend offline, but please be aware that I'm very pleased to see you in person. This doesn't have any impact on your final evaluation. And I think the impact also on your final education is limited. But I think that it's a better opportunity for you, indeed, if you want to profit at most from this exam, to be here. So I'm really grateful to those who are attending physically today in this room. I am also grateful to the many students that are attending online. Now, today we have 3 hours, and the total amount of lectures is 24 hours. So we will have 8 lectures, 3 hours each. The plan is, for me, if you agree, to make a break after 90 minutes, because each hour includes 45 minutes of lectures. So my plan is to teach for the first 2 blocks continuously, and after 90 minutes, make a 15 minutes break. And then we have the last 45 minutes. If you prefer to have a break of 15 minutes each hour, you just have to tell me, no problem, okay? And for those of you who are attending remotely, please feel free to step in with the micro, because I think, again, that the interaction is important. So if you step in with the micro, I can listen to your voice, and it makes the interaction much more engaging. Today, I will start with an introduction, an explanation of how I am planning, together with my colleagues, to teach this course, how the exam is made, a lot of details that will take about, I think, 60 minutes, because I'm quite long in providing this introduction, because I think that a good knowledge of all the details allows you to profit at most from this experience. And then I will start my first real, let me call it in this way, lecture. And then we will see each other next Monday. Do you have any questions so far? Okay, very good. Another thing, please, when you step in to ask questions, remotely or in physical presence, or with your voice or with the chat, please make an effort to write in English. If you really cannot, I can translate for you, but make an effort to write in English, because interaction is necessary. So everybody should be able to understand you. There are many foreign students in this audience. So this is, again, an added value, because it is another reason for the audience to be proud of being diverse. But on the other hand, let's try to speak in the language, in the official language of the subject. Of course, there are few native speakers among us, but this is not a problem. I mean, don't feel shy if you think that your English is not perfect. My English is not perfect at all. This is this is normal. Okay, so let me share my screen. Very good. I think remotely you can see the screen of my browser now, and also in the room. I'm sorry, in the room there is a bit of a problem, because the screen is a little bit moving, is vibrating a little bit. I'm sorry for that. I made the assistant aware of the problem. They said we'll take care of it, but not today. What you see here, it's my website, and the address of my personal website is www.albertomontanari, without spaces, .it. It is in the address bar. I'm not sure if you can see it on the screen in the room. You can get it also from my personal website in Unibo. If you go to my personal website in Unibo, you see that there is, which is here, and it's easy to find on Google, you see that there is the link to my personal website here. Go to personal website. I am making reference to my personal website for interacting with the students for a number of reasons, and let me tell you the two most important ones. Openness, because my website is open to the world, and I really like that my educational material, the educational material that I make available to the students, is available to everybody. And if I use the means offered by the university, they have access reserved to students, which is fine as long as you are a student, but when you get your degree, you will not be a student anymore. And then the information will be not accessible anymore. My aim instead is to give to you an information that is evolving continuously. I make an effort to keep it up to date and available to you even later. So this is why, first reason. Second reason, flexibility. My website offers to me more flexibility because I don't have the security requirements of the university server. So it's more flexible. And third reason, which is connected to the first, I am really motivated to pursue open education, open science, open teaching. I think in order to address the global challenges, this is another fundamental ingredient of the successful recipe. So this is why I want to be really open. And keep in mind that in my website, everything you see there is open access. So if you want to use it, you can just provide the, if you are keen enough, the reference, the source, but you can use it. Of course, unless it is differently specified. There are a few things that are copyrighted, and then there is the indication of that. And this is very useful to you. Given that I am struggling to make my teaching material available open access, I can tell you that it's really not easy on the web to find open access material. There is a lot of material in the web, but only a limited amount of that can be reused. So beware of this. Of course, unfortunately, sorry, 1 second. I need to go back to Teams, but just 30 seconds, just 1 second. Okay. Please remember for the next time, please don't connect to the Teams room anymore, okay? Because otherwise it becomes a nightmare. As I said, it's not easy to find open access material. So this is why I am really motivated to make everything available. And beware of this fact, because unfortunately, it happens quite frequently that students experience some problems because they are using material that they found on the web, which is not free. And the fines are quite, concerning. And for the same reason, be careful in my website when you follow links, because I will tell you later that I have several links available in my website, and you get to another website, be careful of reusing the material that is outside my website. So I tell you, everything you find there can be reused, but not outside from my website. Be very careful. And of course, be very careful when you cut and paste something and you don't provide the source, because this is another criminal offense, and therefore you have to be very careful. But I think that you know this. Okay, now let me go back to my website, which is here, as I said. And first of all, let me start by saying a few words about me and the opportunities given by my website, because you see that it has two columns. One is teaching and one is research. So if you are curious to know what is the subject of my research activities, you can look at the right column. This is just for your information, if you like it. Instead, you must look for the teaching at the left column. So let me say something about me. I think it is important because when you meet a professor, it is important that you get a perception of what the professor can offer to you. And of course, depending on the background, depending on the main field of work, you may expect different things. Let me start by saying that usually professors say that we have 4 legs or 4 pillars of work. One is teaching, the other one is research, and then there is administration and then consultancy. And we say that ideally, a professor should try to experience all of them. It's not easy. So teaching is clear what is. Research is one of our institutional duties. We are committed to make research, and we are requested to make research, and we are evaluated for our research activity. We are also evaluated for our teaching activity. Research is also something that is easy to understand because it means trying to provide some innovation to be used also in teaching. Administration, the university is governed by professors, and this is a distinguishing feature of the university. The definition of university is precisely an independent educational institution that is governed by professors. Keep in mind that it has not been, in the past it was not like that. When the universities were started, University of Bologna was founded, as you may know, in 1088. It was governed by students because the students had the need of educating themselves, and then they were the ones that hired the professors and asked the professor, told the professor what to teach. And this organization worked well in ancient times when the students were coming from really very rich families, which could afford also the economic effort of financing it. Later on, the system changed. The university was then governed by the professors. Today, it's governed by a mix of professors and with some representative from the administrative staff and the students. But the main responsibilities and the legal responsible person for the university is the rector, who is a professor. So, given that we are responsible for the governance of the university, we are required also to take some administrative duties with a different level of involvement, depending also on the personal preferences. And some positions are elective positions, and therefore, of course, it depends also on the opportunities. The fourth pillar is consultancy, which means that we offer service typically to public bodies, consultancy service for trying to resolve problems or setting up new policies, new management procedures. And usually when the problem to be solved requires the use of some innovation, requires creativity, requires research, then the body that is asked to provide the consultancy activity is a research institution. So these are the 4 pillars. Here you can see that I am dedicating space to the 2 main pillars of my activity, teaching and research. I am also involved in administration and consultancy, and you can find around, if you look around to my website, the details. But the majority of my time, my working time, is dedicated to teaching and research, probably more research than teaching, but it depends also on the period of the year, and it depends also on the step of the career. What is my field of research? I am a civil engineer. My background is civil engineering. But soon after getting my master's degree in engineering, I took a PhD in hydrology, which is the science of the water cycle. It's the science studying the water cycle. And in particular, I became very interested in flood management, later on drought management, and water resources management. This is my broad field, and my main interest is in studying change, the impact of change, processes leading to change, but within the perimeter, the boundary of hydrology, because if I had to say what is my field of research in one word, I would say hydrology. If I'm allowed a few more words, I would say exactly floods, droughts, water resources management. From the perspective of engineering, engineering is a science. We will discuss about this. Of course, it's a science with a focus on problem solving and in particular technical problem solving. Today, engineering as other sciences evolved, became more interdisciplinary, so became connected to physics, to economics, and to social sciences as well. But this is my background. And I'm not doing any professional activity now, and therefore I don't have professional experience. It is quite usual for professors in engineering to have also professional experience. I have experience in consultancy, but not professional experience. And this is an important information for you, because you should know that I am basically a researcher. I hope I can say that I am a researcher, but for sure I cannot say that I am a professional engineer. Now, given that I am interested in floods, droughts, you can understand that already at the beginning of my career, I got involved in studying climate change. But my perspective is the perspective of engineering. I'm not a climate scientist. So it's useful that you know this. You will get a lecture from Professor Navarra. Professor Navarra is a climate scientist. I studied a lot of climate science because, of course, dealing with climate change, I wanted to get the background. I studied a lot about climate change. But if I had to say in a few words, what is my experience and my expertise in climate change, I would say adaptation, not mitigation. Mitigation means that we try to remove climate change. Adaptation means that we try to find solutions for limiting the impact. So this is my main expertise. I will talk to you about climate change mitigation. But again, it's not my field of research. I can teach it, but I don't have any publication, any scientific publication on that. Okay. And keep in mind that I think, this is my opinion, I think that in order to contribute to solve the climate change problem, we need both of them, mitigation and adaptation. At least for the time scales, adaptation has an immediate effect, mitigation is delayed. So I think we need an integration. But climate science, as you will see, and in particular climate change science, now has several different interpretations. So this is the first thing that I want to tell you. You listen to my opinion, you will listen to the opinion of other professors. Try to listen from several different opinions. If you really like this subject, if you really want to get it, look at the web, browse it. The problem is not to find information. The problem is to select the information because it's too much. But try to get a different perspective. I will make an effort to give to you different perspectives. So I will also give to you some indication to read some papers which I don't agree with, but this is the nice thing of science. Science is confrontation. Science is not unanimous agreement. When you see in science unanimous agreement on something, you have to get really a little bit skeptical, because science means exploring something that is not known, which we don't know. If we knew the solution, if we knew what is causing climate change, it wouldn't be a subject for scientific research. It is a subject for scientific research because we have many question marks open on the solutions, optimal integration of solutions, on what caused it, let's say, with priority, because we know there are several factors causing climate change. So if we knew everything, it wouldn't be a subject of research. It is a subject of research. It means that we have unknowns. And when there are unknowns, it is normal and beneficial to have different interpretations. So, I mean, I don't think this is a problem, but it is something that I really want to clarify because it's a subject of discussions that are quite animated. Okay, now, I think that I said enough about me. And if you have any question related to my subject of research, etc., you can ask me. You can ask in the chat, you can send an email. Keep in mind that I really like very much the chat for discussion. So I think that the chat is open. If you have a question, it may be that others are interested. So I really like the chat. We can use the Teams chat. It is very useful for this. I will use the Teams chat to send you links, to send you papers, attachments, etc. And you can use it for asking me questions. I'm not checking the chat every day. I am teaching several courses. You have to be a little bit patient with me. But once in a while, I check it. If you have instead questions that are more urgent, maybe not directly related to the educational material, but maybe related to the date of exam or something like that, it's better if you use the email because it's more immediate to reach me. The email is in my website, you see up here, alberto.montanari@unibo.it. Good. Okay, now let's look at my website in the teaching columns. The third link is Science of Climate Change and Climate Actions 2022. Let's click there. And we get to this page, which is an introduction. And here there is a summary of what I'm saying now. So let's browse the summary, something I have already said. But it's useful if we check that I didn't forget anything. So first of all, the study plan is what you can see here. Keep in mind that it probably will be adapted a little bit, depending on your input, depending on the timing, and maybe that something is added, something is removed. But basically, it's climate history, and then advanced techniques for environmental monitoring, climate physics and modeling. How is climate modeled? Modeling of climate-related processes, water cycle and natural hazards, solutions for climate change mitigation and below adaptation, and climate analysis with open data and open software. Again, the treatment will not be a treatment like we used to do at the faculty at the School of Engineering. It will be conceptual, not technical. Of course, there are a few formulas, but actually very few. And I'm sure that you will not have any problem independently of your background. The room will be this one. You already know, I think, that you have to book your physical presence with presente.unibo.it. So I think you already know this. You have the opportunity to get a simultaneous translation in Italian, and I really would like to thank the persons who are offering this service. They are personnel from the University of Bologna. And here is the calendar, and you will see that we should finish on May 2nd. With a long break for the Easter break and for a commitment that I have from April 11 to May 2nd. The first two lectures will be delivered by me, and then Professor Veronica Rossi, then Professor Navarra, again me, Professor Gargini for 2 lectures, and finally I will close the course. The tutorial documents. I like to make my tutorials, and I'm talking for my tutorials. My colleagues are using a different approach in the form of web pages. Why? Because of the openness of web pages. They are open to everybody. But of course, I could make available also on my website the PDFs. I like web pages rather than PDF because they can be easily updated. I am updating my web pages very frequently. And they can include links. I really feel that providing links is important. Also for the reason that by following the links, you learn how to make a selection of the information that you find on the web. It is important that you are able to make a selection. Of course, I could provide the same lectures in PDF and with a clickable PDF to follow the links. What I don't like of the PDF is that it is then circulating in several different versions, changing every month, and then it becomes a little bit of a problem, because I think really the value of having something available that is updated, the last version is important. If you really want to get a PDF, it is very easy to print the web page. I just would like to point out that my website is still not mobile friendly. It is fine on the tablet. On the mobile phone, it's still not mobile friendly. I am getting it, but not before the end of this course. So what does it mean, a web page? I'm clicking, for instance, on the first one, and you see that this is the first lecture. It is a web page with figures, with links, with boxes, etc. Let me now go back because we are not yet at the time of looking at the first lecture. Here there is a list of the lectures. When you go to those given by my colleagues, if you click on the link, you are sent to virtuale.unibo.it. And here, if you get in, you get to the web page that is making available the slides of my colleagues. The reason why I don't want to put the slides available on my website is that they have some reservation because they use copyrighted material also. So they should elaborate a different version, and they feel that the copyrighted material is really necessary for them to be clear. So for this reason, their educational material is not available here, but it's available for you, okay? Okay, now, the same tutorials are available on Virtuale, even mine, because on Virtuale, if you click there on my lectures, you are redirected to my website. So you have the opportunity also to get there through Virtuale. Okay, then videos of the lectures. They will be available on 2 channels. YouTube, because I really want, as I said, to make it open. So here there is a link of the playlist of science of climate change and climate actions, and it is still empty, of course. But from tomorrow or Wednesday at the latest, you will be able to find here the lectures. The second channel is the same video will be made available on Virtuale, on Panopto, okay? But it is the same video, it's a copy. It's not a Panopto video, it's a registration from Zoom. The only difference is that in YouTube, you may get some advertisement. In Panopto, you don't get it. But YouTube is available to everybody, Panopto not. Okay, so the video are available, don't worry about that. The videos will include the break, because if I stop the registration during the break, then I forget to turn it on when I restart lecturing. So I prefer to shut down the camera and the microphone, but keep the video open which means that you will have to jump moving forward 15 minutes when I will make the break. Okay, perfect. Now, by the way, in my YouTube channel, if you are interested, you can find videos of my lectures since 2012. I think I was the first at the University of Bologna to start putting lectures available on YouTube, well before the pandemics. So this was an advantage for me when I had to switch to virtual teaching. And because, again, I think that open education is a plus. Exam. There is a final exam with a mark, okay? And the mark is given in terms of 30 as a fraction of 30. And in the scale up to 30, sorry. The mark for, you know, that the mark for passing the exam, the minimum is 18. And so I need to give a mark. You know that there are some exams where you get only a kind of approval without any mark. This is a mark that is contributing to your average. Of course, it's a weighted average, so this is 3 credits. It's not contributing much, but still. And how the exam will be organized? It will be online, but beware that, as you know, the university requires that you take it in physical presence. So it will be a quiz to be completed in physical presence. So I will book a room like this one. You will be asked to bring your personal computer or tablet or mobile phone. The quiz can be taken also on the mobile, even if I suggest that you use the PC, but actually some students do it with the mobile. There are exceptions to the physical presence for reasons that you know better than me. So if you are exempted from the physical presence, you can take the exam remotely, okay? And but you have to apply on students online in order to get your exemption. After you applied, I get a signal, a green light, allowing you to take the exam remotely. So for instance, foreign students are exempted for now, but be aware of the fact that these exceptions will be reduced in the future, because of course, it's in order to give to all of you the opportunity to get a coherent assessment of your preparation, we should put you in the same conditions for taking the exam. There are advantages and disadvantages to take the exam online. I think you know better than me. And how the quiz is organized. It will be 30 questions with multiple choices. Only one answer is correct, and there is no penalty for wrong answers. Clear? Multiple choices. Some of the questions will have 3 choices. I think the vibration is originated by the air, the heating. Okay, sorry. The vibration of the screen, I meant to say. So multiple choices. Some questions will have 3 alternatives. Some of them will have 6. It depends. But only one is correct again, and there is no penalty for wrong choices. Typically, you don't need to make any computation, or if it is a computation in order to reply, it's very, very simple. So you don't need to use the PC to make the computation. It is very simple. But typically, there are no computations to make because, as I said, the course is conceptual. And 30 questions. To each question is given a mark of, let me say, a quiz mark of 1. So you will end the quiz with a quiz mark, which has a maximum of 30. The final mark of the exam will be a statistical reanalysis of all the marks that are collected by the students. So the moral of the story is that you don't need to answer all the questions to get 30 or to get 30 with laude. It happens sometimes, given that the quiz is changing and given that you are many students, we can make statistics. It happens sometimes that the students who performed best gave 27 correct answers. And then to the students who performed best, it was given the laude. It depends on a relative comparison of your performances. So I want to make you very comfortable, to feel very comfortable. It is a quiz, but you don't need to answer to all the questions. And the time for the quiz is 30 minutes. When? I cannot make any exam before the end of the lectures. So the teaching period, I think, ends this year on June 6 or 7. I don't remember, but we can, I think it is written here. Let me see. No, it's not written here, but I think it is around June 7. So we will agree a first date soon after June 7 or 6, like June 8 or June 10, it's the first date, okay? And then I will fix a second date after 2 weeks and another third date before the end of July, typically mid-July. So a possibility is June 10, June 24, July 15. So you will have 3 opportunities before summer, before August, let's say. And you can decline the mark and make the exam the next time if you wish. So there is no limitation on that. I don't formally register any negative mark or whatever, okay? I will fix another date in September, typically September 15. And then I will go to Christmas. And then again, end of January. This is what I did this year, last year, sorry. 3 dates before end of July, 1 date in September, 1 date in December, 1 date in January. With the same mode, the quiz, 30 minutes, etc. The dates of the exam will be fixed later, but not much later. Let's wait in March in order to have an idea also of how the situation is evolving with the. I am very optimistic this year about the possibility to give the lecture in physical presence, but let's see how it goes. Any question so far? Let me check the chat. I think I already answered some of them, where we can find the final recording of each lesson. A WhatsApp group is up to you. Please don't put me in the WhatsApp group. And but I also encourage you to use the chat on Teams because I think I am reading and I can attend also your discussion if you wish. The Teams link can be found here. The Teams link can be found here. If you go to my website into Unibo, which is here, and then you go on teaching. Let me put it in English. Teaching. There is science of climate change somewhere here. Online lessons. This is the Teams link. Okay, and I think that I answered all the questions on the chat. Let me check on Teams because I need to be multitasking. Okay, good. No questions from the room, so it's we still have 20 minutes to go. I think I can then start, but let me just make a final check if I said everything. Okay, I think I am fine. Now let's click on the first lecture. The climate change problem. You see the link here. Let's try to click here. So this lecture, let me just increase the font size and let me do like this. Perfect. Okay, if you go at the bottom of the lecture of each page, in some pages you find a PowerPoint to be downloaded. Download the PowerPoint presentation of this lecture. I am using this PowerPoint to teach. I suggest you not to use it for preparing your exam because you are missing many details. When you study for your exam, look at the web pages. Everything regarding everything that is composing any question that is in the quiz can be answered if you look at the web pages. Just 1 second. Okay. So everything can be, as I said, any question can be answered by looking in these web pages. But you understand that if I teach by using the web page, it's a little bit difficult to follow on the screen. So let me use the PowerPoint for teaching. Otherwise, you get distracted in reading, and it's not a good thing. Just 1 second. Good. Okay, so the title is the climate change problem. You don't see it here, but the purpose of this first lecture is to give you an idea of what is the problem here, why we are teaching this. First of all, it's not easy to find courses on climate change. And the reason is that, as I said, is a challenging issue that it's not easy to teach. So let's see, I'm curious in hearing your opinion at the end of the course when you will compile the student's assessment. Climate change is strictly related to sustainability. Strictly, when you talk about sustainability, then you get involved in climate change. From my perspective, I started studying hydrology, water resources management, and I realized when writing my first papers that I needed to study climate change. Because, of course, when we talk about a challenge that is related to a natural resource, when we talk about sustainability of some natural resources, including air, including water, including food, then you get to deal with climate change. And why we have this problem today? I think it is important to get a perspective on this, because climate was continuously changing during the history of Earth, with changes that have been very dramatic in some of for instance, during glaciations. Professor Veronica Rossi will tell you something about that. So climate has always been changing. So what is the matter today? And why sustainability is becoming a topical issue today? What is the reason? First, let me say that sustainability, when the humanity started to organize social life, in a quite evolved manner, sustainability was already a problem. For instance, in the ancient Greece, the management of wastes from the city of Athens was really demanding, was really an issue. They didn't have, in the early history of Athens, they didn't have a system for collecting wastes, and the wastes were accumulating into the city. This is an example of a first problem to deal with sustainability. But also, if you think about the Egyptians, ancient Egypt, they had to manage their relationship with the Nile River to make it sustainable, to make their social life, social organization sustainable, to get enough food for a civilization that was expanding. So it is a problem that is quite, old. But today there is a new issue. There is a new driver, and the driver is speed. Speed of social evolution. Of course, it's difficult to say if the changes that we are living now are unprecedented. Also in the past, we had dramatic changes. Think at the Roman Empire, its collapse, and what happened after the collapse of the Roman Empire. By the way, it seems that the Roman Empire collapsed. One of the causes, one of the drivers of the collapse was indeed climate change. But the changes were really relevant also in the past. What is probably, I say probably because these are, issues that are difficult to prove. These are statements that are difficult to prove. But what is different probably is the speed, it's the pace. Because if you look at our society in 1850 and now, after 170 years, probably the change is more dramatic with respect to the changes that we had from 1600 to 1800. Because there has been a social evolution that has been really impressive. New technologies, new needs for humans, the welfare increased a lot, the average life. I think probably in the past, the average duration of our life didn't increase so quickly. Now it's really, the average duration of our life is really increasing very quickly. And so on the one hand, this is very good. And it was the Industrial Revolution that started this. The availability of energy, steam power, the availability of new mechanisms for producing new technologies. On the other hand, of course, we got the problems. Problems like pollution, like air pollution, water pollution, increasing water demands, increasing needs for food, because the global population is increasing dramatically. Probably the pace of the increase has never been so rapid. And when you concentrate people living in small areas, you get pollution, you get problem of sustainability. Our relationship with the environment needs to be sustainable. And this is a new challenge that is emerging and emerging. If you look back 50 years from now, 1970, the word sustainability was not known, not a problem at all. If we look at water resources management, the first problems were in the 60s of past century, 50 years ago. I was born in 66, and the first water declaration was issued in Europe in 1968. It's the first declaration which says that saving water is important. In the past, no problem. Only 50 years ago, we realized that we didn't have enough water for everybody. In fact, there was a real feeling that by the year 2000, we could run out of water, out of fresh water. Fortunately, this did not happen. Just to let you know that this is a modern problem, which is motivated by something that is good, But everything that is good brings some drawbacks and also some bad management, some bad politics, some, some bad strategies. Because when you get new means, new opportunities, if we don't manage them well, we create disparity, disequality. Okay, and this happened frequently in the past, and it's still happening now. So I think that the problem of sustainability includes many different facets, many different sub-problems. One is climate change. Climate change is reducing our capability to make our development sustainable. Another issue is water resources. They are to some extent related to climate change, but even if the climate was not changing, we would anyway have the problem of scarce water resources because of increasing demands, which is fine, I mean, but we cannot live today with the same amount of water as my dad in 1930, my granddad, sorry, in 1930. They used really a small amount of water. Today we use, when we design a water supply system, we design it based on the number of inhabitants. And we count in a city like Bologna, 400 liters per day per person. This is what we count. And very often we still have some crisis. Okay, this includes the industrial use. But even for very small towns, even for a single house, we design for 150 liters per person per day. And you may say, impossible, I'm not using that water. I bet that you do. You don't realize it, but I bet that you do. Anytime that you flush the toilet is 5 liters. Anytime that you take a shower is 30 liters. Just to give you some examples. So you understand that you easily get to 150. And I bet that if you were forced to live with 30 liters per day, your life would become really difficult. Because if you take the shower, you cannot flush the toilet, or you have to take a very short shower. So, I mean, this is good because if we use water, it's because we like it and because we want to increase our welfare. We want to increase the quality of our social life. On the other hand, water is another problem. You probably heard about the water, food, energy nexus. Water, food, energy. They are directly related because we use water to produce energy, and we use water to produce food, and we use energy to produce food. And when we talk about water consumption, 70% of the human consumption of water is water for irrigation. This is a big, relevant sub-problem of sustainability. For some reason, climate change is more concerning. It shouldn't be. It shouldn't be more concerning. They should be both concerned in the same way. But water, for some reason, is considered to be a local problem. Climate change is considered to be a global problem. I don't really think this is a good perception. I think they should be considered together. Climate change, water resources, water-related hazards, they should be studied with a comprehensive and transdisciplinary approach. What does it mean, transdisciplinary? I think you understand what disciplinary means. It means that I study water by looking at hydrology. Hydrological science gives to me the theory to study water, and that's it. I study climate by looking at atmospheric sciences and physics. They give me the theory, and that's it. Interdisciplinary means that I look at both of them because I understand that climate change and water resources are correlated. So I look at both disciplines. Transdisciplinary means that I found a new discipline, and this is what we need for dealing with climate change. We need a comprehensive approach, something new, including economics, I don't think we can study climate change mitigation if we don't study economics, because we have to find alternative ways to produce energy. So this requires a political decision, which is supported by an economic strategy. So we need really a comprehensive approach. It is absolutely not easy, absolutely. Here you see some pictures that show to you the problem. Let's look at let's forget the big one. The big one is just a lake, an artificial lake with a low level. Okay, that's fine. It's a clear indication that it may be that the low level is given by climate change, less rainfall, or it may be an intake that is increasing. Again, climate change and water resources are connected. Water scarcity is connected to climate change, and water scarcity is influencing water resources management. Let's forget about it. Let's look at the right of the big picture. You have a glacier. You can find several pictures like this one. And it's a glacier in 1900, 1950, 2015. It's a glacier in the Svalbard Highlands. The extension of the glacier is decreasing. I mean, there is no doubt that we are living in a period of global warming. There is no doubt on that. Let's be very clear. Glaciers don't lie. So, I mean, there is no discussion on this. We can discuss on the causes, because actually, you see that even from 1900 to 1960, there was a huge decrease of the glacier. And the CO2 concentration was not so high during that period. So maybe that it's something different or a combination of causes. But there is no doubt that we are living in a period of warming. No doubt. Let's go down to the lower left picture. This is the minimum, annual minimum of the Po River. Minimum of what? You can say water level or water discharge. The discharge is the volume of water that flows per unit time in the river. It is already something technical. You don't need to remember that. Let's talk about the minimum level, even if it is more correct to talk about the discharge, because the level can be influenced by the change in elevation of the land. You know that the land goes up and down. In this region goes down because of subsidence. So the level is not really that meaningful, but it is comparable to the discharge. So, and is easier to understand. So what you see is that if I draw what we call a regression line in engineering, which means a tendency, an overall tendency, it is decreasing. It means that there is less water. And look on the right, you see that there is a strong, a very low minimum. This is the big drought of 2003, which hit almost all of Europe. And then we recovered. Another interesting thing that you can get from this picture of the minimum of the Po River, annual minimum, is the fluctuations. Climate is not a stable thing. Climate is not like this table, which is there, fixed position. Climate is varying. And this makes the problem more complicated, because of course, if you have a house, it's stable. If you get if you see a fissure in a wall, then it's clear that something changed. Climate is something that is dynamic, evolving. In the lower right, you see a picture of explaining the evolution of La Nina. What is La Nina? You heard about El Nino, La Nina. What is this phenomenon which basically is a possible explanation for this fluctuation of the minima of the Po River. There are some patterns in atmospheric circulation, means the movement of masses of air in the atmosphere, that when they start, they last for a while. So if there is a movement of mass of air in the atmosphere, and the air contains also water vapor, when this movement starts, then it may last for a long time and generate perturbations of the climate. El Niño in particular is a difference in temperature between, in the Pacific Ocean, between the coasts of Australia and the coasts of South America. Look at Wikipedia for some more detailed description, but basically when you have this difference in temperature, there are streams that move in the oceans in a certain direction. And these streams can last for a while. And the streams of hot water or warm water generate perturbation of the climate that lasts for a long time. It is not clear if global warming is influencing this effect. So it is not clear if global warming is intensifying the frequency of droughts. It is clear that global warming is exacerbating the impact of droughts. It is clear because, of course, if you have more evaporation during a drought, then you suffer more. It's not clear whether the occurrence of a drought is exacerbated by global warming. Why I'm saying this to you? To clarify the unknowns, to give you some examples of unknowns. We know that climate is changing, but we know little of it. This is why it's a problem. This is one of the reasons. There are several reasons why it's a problem. One of the problems is limited scientific knowledge. Don't assume that we know everything of nature. And in particular, don't assume that we know everything of climate. There are trivial things that we don't know. Before making the break, I give you another example of a very trivial thing that we don't know. In terms of floods, we still don't know if after a rainfall, after an extreme rainfall, we still don't know if in a natural environment, what is the water path before it floods. So we know that there is an extreme rainfall. We know that there is a flood downstream, but what path does the water follow from the time when it gets to the ground to the time when it floods? We don't know. We don't know if it goes underground or if it remains on the surface. We don't know it. Actually, we had demonstrations during a flood. We got demonstrations through isotopic analysis that the water that flooded was rained 1 year before. You couldn't believe that. It is true. Because it was water already stored into the ground, and then the extreme rainfall basically sorted the fact that the break was released. It is like you get a dam that keeps a lot of water behind it, and you get an extreme rainfall and the dam breaks. So what caused the flood is the rainfall, because the rainfall gave an additional load over the dam. But the water that drowns people, it's water that was in the dam, not the water that rained. But of course, this is a trivial example. What actually happens in nature, we still don't know. So we don't have to assume that we know everything. We don't have to assume that we can control everything. And this is why climate change is a problem. Do you have any questions so far before I make a break? There is a question in the room. Please try to. I don't understand what a flood is. Ah, what is a flood? Okay. Are you Italian? Yeah. Okay. Alluvione. A flood in English is an overflow of water from a river. Yeah. Other questions? Okay, let's meet again in 15 minutes from now, and then I will teach for 45 minutes more. Okay, or less than that, 40 minutes, because I went a little bit beyond. Okay, I think we can restart. This slide gives to you some examples of unsustainable impact of societal development. These are very trivial examples: intensive agriculture, construction on dams and river barrages, increased demands for energy, and the concentration of carbon dioxide in the atmosphere. Actually, the last one is consequence of some of the first impacts that are shown here. Intensive agriculture is indeed impactful for several reasons, including the increase of CO2 emissions. Other reasons of impact are related to irrigation, to the need for energy, which in turn implies an increase of CO2 emissions. Dams and river barrages are built for producing energy and delivering water for civil or industrial use or for irrigation. And their impact on the environment is considerable, also in terms of changes that can be induced on the climate, because there is an increase of evaporation in the vicinity of the dam, and there is a deprivation of recharge to groundwater resources. Because of course, given that a dam retains water upstream, then there is a decrease of water downstream during there is an alteration of the normal water flow, which causes an alteration of the groundwater resources. Energy, of course, increased demand for energy means that we need to produce energy, and still we are producing much of our energy by burning fossil fuels. And this is impacting. I want to give you an example by opening another web page about a problem that was caused, sorry, this is a new PowerPoint page, is not what I need. An example of a problem that was caused by river damming, which is the Lake Aral disaster. I'm looking in Google, and let's see the Wikipedia page. Just 1 second. What you see here, these are two pictures of the Lake Aral. They were taken in, let me just look at the 1989 on the left, 2014 on the right. And the picture of 1989 is already referred to a partially impacted situation. So Lake Aral almost disappeared. And what you see in place of the lake is a white spot. The white spot is salinity, because Lake Aral was a salt water, so it's salt. Why this was caused? It was caused because the former Soviet Union needed a lot of water to cultivate cotton. And therefore they dammed the river, bringing water to the Lake Aral, and diverted the water for irrigation. And so the lake shrunk, and in turn, the reduced evaporation from the lake caused a change of the local rainfall, which went down and therefore further contributed. So now the disaster, it's impossible to recover. Even if the dams were removed, still it's impossible to recover. And a similar situation is occurring in the Lake Urmia. Even in this case, river damming caused a climate change and contributed to the disaster. So this is just an example of what retaining water for food, for irrigation can cause. And it's not just a lake that doesn't exist, a sea, because the extension of the Aral Lake, I think it was, let me check, the second lake, the Aral Sea, just 1 second. Formerly the 4th largest lake in the world, with an area of 78 square kilometers. And it began shrinking in the 60s after the rivers that fed it were diverted by Soviet irrigation projects. And if you read the page, you also see that now there is a problem of reduced rainfall or the reduced evaporation. This is just an example of a disaster that is very meaningful. Just 1 second, I'm going back to here. Now, let's focus on climate change. So far, we made some examples of unsustainable situations with some reference to climate change. Now let's focus on it. And let's understand what is climate change. What do we mean with the term climate change? Okay. Definition. Look, in this subject, in this course, we focus on science. Our objective is to learn and discuss the science of climate change and the science that should support our actions to mitigate it. And given that we want to discuss science, it is important that we are very rigorous. I mean, we are not discussing opinions here. We have to discuss with a rigorous approach scientific concepts. Therefore, definitions are very important because, as I said, science requires rigor. Rigor also means be clear with the definitions and with the usage of terms, because very often during discussions, some confrontation may arise because we don't use proper terms. Okay, good. So what is climate change? What is the definition? It is a significant, I am reading, and long-term change in the statistics of weather patterns. So we didn't understand. We still don't understand. First, what is weather? Okay, weather is defined as the combination of meteorological behaviors at a given location and time. This is weather. Okay, so it's what in Italian we call il tempo, meteorological. Weather means meteorology at a given location and time. Okay, what is then climate? Can be defined as the long-term distribution of weather statistics for a specific region. So weather refers to a specified time and location. Climate refers to statistics over the same location, statistics of weather. What are statistics? For some of you, it is trivia to define what are the statistics. The statistics describe the distribution of weather a long time. So this is why when we define weather, we talk about a time interval, a time instant, a time. When we say climate, we don't say a time, we say statistics of weather. Again, statistics are the distribution of weather along time. Let me be clear. If I say rainfall in Bologna today, 0, perfect. Tomorrow it may rain. So rainfall in Bologna tomorrow, 10 millimeters. This is weather. It refers to a meteorological variable, a meteorological feature, rainfall at a certain location, Bologna, at a given time, today, tomorrow. What is climate? Average rainfall in Bologna in January. This is climate. Because I computed a statistic, it's the average during a certain time, January. And given that it's an average, I suspect that I am computing it over many Januaries. This is climate. So average, mean value, la media in Italian, is a statistic. Because it describes the distribution of rainfall during time. So it's a statistic. Question?
During the course, are we going to talk also about data distributed over space or only over time?
No, we are going also to talk about data distributed over space. In fact, I was saying that statistics are not only collected over time, they can be collected over space. But given that I am trying to define climate change, now I would like to focus on statistics over time. Another statistic is variability. Average is something, let's say, mean, okay? Variability is how much rainfall can vary up and down, above and below the average. Good. So we know what is weather, meteorology at a given location and time. We know at this point what is climate, long-term distribution of statistics of weather. You see that usually we refer to a minimum time span of 30 years. When I say long-term distribution, long-term statistics of weather, it's at least 30 years conventionally. Now, climate change refers to climate. Climate is a statistics, Climate change is a change in statistics. So it's a change in the statistics of weather patterns. And it should be a significant statistic, a significant change, and a long-term one. Not really a change that lasts for 3 years and then it goes back to normal. We don't refer to this as climate change. We call this climate variability. Okay, if I have a drought, less rainfall lasts for 5 years and then goes back to normal. This is climate variability. If I have a drought that is starting and then again and again and again, worsening, 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 for 30 years, this is climate change. There is something more to be said about climate change. When we say climate change, implicitly, conventionally, we imply that it's human-induced. Actually, this is not really specified in the definition. So climate change, one may say, can also be natural. Why not? But in our current terminology, when we say climate change, we usually imply that it's human-induced. If it's not human-induced, we tend to define it as natural variability. If it's not human-induced, it's natural, correct? or natural change, but actually natural change is not used. Natural variability. Climate change, as I said, has many different connotations. It may manifest itself with in several different modes. I give to you an example here on the picture on the right. These are temperatures from 1907 to 2007, 100 years. It's a long time span. Temperatures in several different cities in Japan, and they have different size. And you see that there is a general increase, but you see that Tokyo increased much more. Why? For the heat island effect. The heat island effect, you can get by intuition what it means. And if you are used to drive a motorbike or a sport car, you can perceive it. When you get into a city, you feel like warmer. This is the heat island effect. It's caused by the urban radiation, by the heating of the houses, by the lack of a cooling effect given by the presence of vegetation. Vegetation through evaporation subtracts heat. And therefore, inside the city, you have this climate change. And you may say, I'm not interested in that because it's very local. Actually, there have been studies reporting that the urban heat island effect caused many losses of lives, because, of course, when we talk about global warming, usually we refer to an average. But in the cities, you may have a warming during the past 30 years of 3-4 degrees. And you understand that this is causing relevant problems to the health of people. So actually, it's something that cannot be ignored. And I am mentioning it to you because I just want to tell you that it's not only greenhouse effect. There are several causes for global warming. And in this case, it's not global, but local warming. And still, this is an example of climate change. It is human-induced, it is long-term. Often it is not really a matter of concern, but actually science has shown that it is concerning. Okay, now we know what is. And there is a big problem here. Attribution of climate change. What is causing climate change? This is our main question mark that I want to discuss with you. Of course, we have some, before I move forward, look at the picture on the left, on the right, and it shows, unfortunately, it's difficult to see the here there, but in the bottom of the picture, there is the here depicted. Is a movie that is repeating and is showing the global increase of temperature from 1950 to 2013. And you see that at the end, there is the red that is spreading. And you see that there are some hot spots. Sometimes we talk about global warming and we think that there has been a global increase of temperature, which is spatially constant, which is not the case. There are some places, typically the southern hemisphere, where temperature is increased less. And some places, typically in the northern hemisphere, where it increased more. And there are hotspots, the Greenland, the Alps. In the Alps, we had an increase of average temperature, which is close to 2 degrees from the pre-industrial period. It's not clear why. It's not clear why in the Alps. And if you look at the Alps, it's not easy here, but you see that indeed there is the color that is dark orange, let me call it in this way. So here the question is, to what extent humans are responsible for the recent climate change? There is no doubt that the human activity is impacting climate, and I want to be clear also on that. The discussion is not whether or not humans are responsible. there is no doubt that we are responsible for it. There is no doubt. Even the most skeptic researcher would recognize that there is no doubt on that. The heat island effect is a clear demonstration. The question is, to what extent it is human induced? It is 10%, 20, 90, 99, 100% human induced, or there is some natural variability in it. And you may think, why this is so important? I mean, once that we recognize that there is a human contribution, why should we define the percentage of the human contribution? It is essential for mitigating it. If you want to mitigate, if you want to solve the problem, mitigation, adaptation, you need to identify the causes of the problem. We engineers say that the first step to solve a problem is to identify the cause. When you go to the medical doctor and you say, I have a pain in my neck, so the doctor, the first thing, makes sure that you don't have something very bad. Because the problem is, the first step is to identify the cause of your neck pain. Okay, it's clear. And then if you find the cause, you find the solution. But if we don't identify what is the human contribution, let's suppose that the human contribution is 50% of it. Then it means that we don't have to only look at reducing emissions. We have to reduce emissions. Of course, it's never wrong to reduce emissions, but then we have to adapt to it a little bit, because reducing emissions would solve only 50% of it. And therefore, we have to identify another strategy to integrate with the reduction of the emissions. It looks trivial. It looks very trivial. The example that I made of the medical doctor is very trivial. But it is essential to clarify that this is really needed. And I want to clarify it because this is a matter of discussion. Some researchers say, why are you interested in quantifying what is the driver? Once that you recognize that we humans have a responsibility, why should you look at it? And I reply by saying, because I am in charge as an engineer of finding a solution. And the first step is to identify the drivers of the problem. And even if it was anthropogenic, think about it. I need to understand if it is a change in climate given by increased emissions, or a change in climate given by the fact that I modified evaporation because I urbanized the land. So I reduced evaporation and I changed the climate. I need to identify this, because otherwise, if I reduce emissions and I urbanize everything, I build dam everything, the problem would still be there. It is very important. Now, at this stage, we still have about half an hour to go. I would like to show you a couple of short videos, which are linked in my website. So you take another little bit break, and I think they give you two different perspectives: evidence for climate change. They are titled Evidence for Climate Change and Ice Ages and Climate Cycles, which is dedicated to natural variability. Basically, the second video shows the changes in climate that have been caused by ice ages and climate cycles. So I think it is another and different perspective. The duration is more or less the same. You can have a look. So on the one hand, you have, with the first video that we saw together, a clear demonstration of a clear discussion of the effect of the human activity, so anthropogenic climate change. On the second video, you have a more extended in time picture of past climate fluctuations, which also Professor Rossi will discuss. So you see that it is indeed the attribution, whether it is something natural or something human induced, it is indeed very important. Also, We are talking here about temperature and sea level. These are variables that are quite easy to predict. Why? Because they are very regular. Temperature is not changing rapidly in space and time. If in Bologna you have a certain temperature and if you move 50 kilometers away, you don't have a much different temperature. And the same in time. If today you have a certain temperature in Bologna, the temperature tomorrow is not much different. Think of rainfall. Rainfall is much more varying, much more fluctuating. In summer, it may rain here, and if you move away 1 kilometer, you don't get any rain. And the same in time. Some storms in summer last for 5 minutes. So temperature and sea level are easier to describe, easier to predict. And therefore, it is easier to attribute changes in temperature to human activities or something different. When we talk about other variables like rainfall, much more varying, it becomes really a tough problem to determine whether global warming is increasing rainfall. This is an open question. If you listen to the media, it seems that it's already demonstrated that higher temperature means more rainfall. Actually, this is not universally true. For instance, average rainfall didn't change in the past 30 years, even at the local level. And the extremes still are largely unknown. And of course, we are not interested just in temperature, because, okay, we may, if we have an increase in temperature, we may adapt in some way. If we have an increase in sea level, we may adapt in some way. But if you have the contemporary occurrence of increasing temperature, increasing sea level, increasing extreme rainfall, then it becomes a problem. I mean, I would be relieved to know that even under global warming, I don't have a higher risk of droughts. I would be really relieved. So attribution is really complex, and attribution is the main reason of this controversial discussion surrounding climate change. I mean, the controversy, if you look in Wikipedia, the climate change controversy or global warming controversy, the controversy is not whether there is global warming or not. It's clear that there is global warming. The controversy is attribution. The controversy is whether water resources and floods are affected. This is the controversy. When did we start to become concerned about climate change? I would say already in the 19th century, there were some scientists that had the intuition that the human activity may cause climate change. But they were not really concerned because they didn't find any evidence that the human activity was dominating on that. One may say that in 1960, we started having some real concerns, and we found the first evidences for the warming effect of carbon dioxide and burning fossil fuels. At the beginning, scientists were concerned by the risk of cooling rather than the risk of warming, because they had the intuition that the spreading of aerosols in the atmosphere may be the cause for a decline of temperature that we experienced from 1950 to 1980. If you remember the graph that was shown in the video of the global temperature, there has been an increase from 1850, but you may have seen that there was a hiatus from 1950 to 1970-80. And at that time, they made a conjecture, they made the assumption that the increase of greenhouse gases could reduce the solar radiation and cause a global cooling. You may look for global cooling in Wikipedia and you see the history of that. Then this assumption has been falsified. And So basically, it was starting from 1990 that we started to be concerned by global warming, and the scientific literature started discussing global warming rather than generically climate change. And today, as I said, we recognize that human activities are impacting, but we still have many questions marks that are open. I talked about a controversy, and I think we need to talk about this because I think you got that climate change is a hot topic from many perspectives. On the one hand, there is a discussion which is not really, I don't think it is the problem, a discussion between scientists about the so-called skeptics and the so-called orthodoxies, if you want to call them with this name. And the discussion is related to the human impact, the human influence. And I don't think this discussion is really relevant because I think that indeed there are many questions open, but I don't think that it is open the question whether or not we are responsible. It is still open the question of to what extent we are responsible, but I don't really think this is a big problem. I think it is a more relevant problem to identify the solutions. Some people are discussing whether we should give the priority to mitigation or to adaptation. I hope you have cleared the difference between them. Some people discuss whether we should, in which way we should change our political strategy, our economic strategy. Politics and economics are strictly related. So I think that it's clear to you the discussion, the criticism that is brought forward by the Greta Thunberg movement and the replies that the politicians gave, replies that basically say it's not easy to make a change. But on the other hand, there are some people suspecting that politicians don't want to make the change because the change is unpopular. And therefore, you know, today we are living in a period where politics is a little bit weak at the international level because in democracy, sometimes it is difficult to take unpopular decisions. So there is also political discussion. And this political discussion is complicated because of the uncertainties. As I said, we don't have a perfect knowledge of the science behind it. There are uncertainties, which is normal in science, as I said. There is no science without uncertainty. On the other hand, the scientific discussion is in a way contaminated by the political discussion. I mean, I think that both politics and science are necessary for the evolution of society. We cannot evolve society without politics. Of course, we need good politics. Like in science, we need good science, but we need both of them. The question is whether they should contaminate each other or stay independent. This is an hot topic. Like, it is clear that science should give support to politics. It is clear that politics should give support to science founding. But should science basically give the answer that the politics needs, or should science be independent and just trying to clarify the truth, try to give a picture of the truth? Should I just try to explain what's going on? Or should I, in a way, direct my research activity in order to support a political action with whom I agree? So, in practice, I agree that I should support a political action reducing CO2 emissions. So should I direct my research to investigate specifically what is the impact of CO2 emissions on climate, or should I investigate both the human impact and natural variability? This means that my resources, not only economic resources, but also science resources, are directed in a way rather than in another way. So some scientists say, no, we should pursue knowledge, innovation independently. Some others say, if you believe that an action should be taken by the politics, let's make an effort to support that action. And this is the cause of the debate, of the discussion. And actually, this course is intended to talk to you about science. So let's try to get an independent view. And then, of course, we may have also some political orientation. And political orientation means that we may have a personal preference for such kind of actions. Like, for instance, I may have a personal preference for adaptation because I am an engineer. So if I am really a passionate and motivated engineer, I should be more motivated to study adaptation. If I am a passionate and motivated climate scientist, I should be more motivated to study mitigation because I want to save climate. As an engineer, I want to save society. And therefore, my priority is adaptation. But let's try to be independent. And again, once again, let me push again the concept of multidisciplinarity, transdisciplinarity better. Interdisciplinarity, better transdisciplinarity. And the role of engineering. This is, I think it's important that I think I already mentioned it. What is the role of engineering? And what is the reason why I am so motivated to emphasize the role of engineering? It's not just the fact that I am an engineer. It is the fact that sometimes I am concerned, maybe because I am an engineer, by the fact that engineering is neglected. And I think this is a potential problem. Some of my colleagues working in climate science, sometimes they tease me, they joke, make fun of me by saying, you are an engineer, you are not a scientist. And indeed, there is this convincement like technology is responsible for climate change, and therefore it shouldn't be a matter for engineers, the study of climate change. Because, I mean, if you think who is responsible of the degradation of environment, dams, infrastructures, roads, cities, engineers are responsible. And therefore there is this convincement that engineers should stay away from that. Actually, I mean, when I was a young boy, I was a fan of the Green Party because I grew up in a very green environment that started disappearing a little bit. I am a passionate mountaineer, so I'm really motivated to preserve the environment. But I am really convinced that to preserve the environment, we have to involve engineering, because if you leave the environment by itself, it's not protecting the environment. Let's make it clear. To protect the environment, we shouldn't leave the earth to go to pristine conditions, because pristine conditions means floods, marshes, unhealthy situations, which are not good also for the survival of the environment. I mean, sometimes we make interventions on the environment to preserve it, because a flood implies a destruction of the environment. Think of a drought. When I go to irrigate some natural resources, natural reserves, sometimes during a drought, they go to irrigate the trees, because otherwise they would disappear. So, I mean, the human intervention, engineering, irrigation is essential to preserve the environment. And sometimes we build dams just to preserve the environment, because we want to save water to be distributed during summer, to avoid the the disaster that is caused by a drought. So I think the role of engineering is indeed important. And let me just now make introduce a concept which is related to climate change, which is the concept of reversibility. Is it reversible, climate change, or not? And I think also engineering is important to give an answer to that. Because I think through adaptation, engineering can help us to avoid reaching what is called a tipping point. What is a tipping point? Let me just show you the next slide. A tipping point for a given system, for instance, climate system, is a state of the system itself such that a tiny change is a critical state. If you make a tiny change, you may lead to a new equilibrium state. And what it means? It means that, for instance, let's suppose that you have a forest that is made of trees, and then you have water scarcity, like a long-term drought. The trees start to suffer, and they get to a critical situation. What happens if you make a small, tiny decrease of rainfall? The trees die. And look, this is what happened with the Vaya storm, wind storm in 2018. You may know, especially the Italians among you know, that the northeast of Italy was hit by a windstorm, a violent windstorm that caused the collapse of several pine trees in the mountains. This is called the Vaya storm. This means that a tipping point was crossed, because after the trees are collapsed, you don't get the trees back anymore unless you go there, remove the dead trees, and plant new ones. If you leave the situation like it is, then you get brushes populating again, and maybe in 1,000 years, maybe that from the brush you pass again to the trees. With a human intervention, you can go back to the previous equilibrium state. The new equilibrium state is brushes, not trees. And this happens quite frequently. Droughts cause the passing of this tipping point. And then if you get again rainfall, or in the case of Vaya, even if you don't have wind anymore, still you don't get back easily to the original configuration. And these tipping points are a peculiar behavior of the climate system. Lake Aral, they crossed a tipping point. They reduced the inflow in the lake, reduced the evaporation. Now, how can they go back? They cannot bring water from somewhere else, from the sea, to replenish the Lake Aral. These tipping points are big question marks, because we only have a glance of them. We don't know them fully. And this is a big problem, because you understand, sometimes we try to make predictions, but not everything can be predicted. And if you cross these tipping points, in my webpage, I have a nice picture of some tipping elements. So elements that may cause the crossing of a tipping points in the Earth's climate system, like melt of the Greenland ice sheet. Let me give you this example and then I close. There are theories that say that there is a lot of water inside Greenland. This is a relatively recent discovery. We learned that in Greenland there is a lot of water into the ice, because if you go deep into the ice, the pressure makes the glaciation of water impossible. There is an high pressure, because you go deep into the ground, and this pressure keeps the water in liquid form. So you have hidden lakes. So the concern is that you reduce the thickness of the ice crust, you reduce, and all of a sudden you may get a huge lake outburst, which means that suddenly you have the melting of a big portion of Greenland, of the ice cover in close to the North Pole. And this may cause a sudden sea level increase. The video was talking about a sea level increase of 1.7 millimeters per year. It's not much concerning. If we had in 1 year an increase of 10 centimeters, it would be concerning. But this may happen. If there is a lot of water, we cannot quantify how much water is hidden into Greenland, into the ice cap, the North ice cap. If there is a lot of it, we may have a sudden lake outburst. And it is something that really we cannot easily predict. And there are some other reasons for suspecting that there might be several tipping points. I hope that I also clarified by giving these examples why the issue is controversial. Different political views. Should science and politics integrate each other, or should they stay independent? Uncertainties, how to deal with them? What are the uncertainties? Is it possible that there is a sudden collapse of the North ice cap? Is climate change due mainly to human activities, or there is a significant portion of natural variability? Is it the superimposition of two variabilities? I hope I gave to you an overview of this problem, which, let me check how many slides still I have to. I think we can stop here, because then I want to talk the next time of the data that can help us to resolve some of these questions that are still open. Let me look at the chat just a second. No, it is okay. Okay, very good. Okay, perfect. And thank you very much. Do you have any question? Okay, oh, please, there is a question in the room, please.
The first part of the lesson, you spoke about the possibility to age the water from a rain. How is it possible?
Yes, the question is how it's possible to determine the age of the water through the isotopes, because there are isotopes. I'm not an expert, but I know that there are isotopes in the rain. And these isotopes are related, they have been classified and dated. So if we find that in the water that is flowing today, there is a certain isotope, we can date it and say this is water that rained 2 months ago or 1 month ago. What you need is a collection of the isotopes in the rain, in the rainfall, in the rainy water, which is not easy. It's quite costly. It's easy to get the samples, but then I had a practical experience, because we wanted to determine, we were taking water from a well for supplying water to a city. And the question was, how old is the water? Because if the water is very young, like yesterday it rained and today I take the water, it means that there is a reduced transit time and there is an high risk of contamination. Instead, if the water is very old, then the risk of contamination goes down, because it means that it goes through filtration, long filtration. And therefore, we took the isotopes from rainfall and the isotopes from the well and could determine that the age of the water was several months. But it was very costly. Any sample costed about 1,000 euros to get one sample analyzed. Yeah.
Thanks.
Yeah. Thank you very much. Grazie. If you have any suggestion, write to me. Okay, very good.